Dear student, in this session, we will discuss subtopic 3.2 Process Scheduling from Unit number 3 Process Management. The course outcome is to execute the process command for performing process management operations, and the learning outcome is you will able to explain the functions carried out in the given process state. In the previous session, we discussed the process state and the process control block. Now, in this session, we will discuss the scheduling queues, schedulers, and the context switch under the process scheduling. Now, let us see what is process scheduling. The objective of multiprogramming is to have some processes running at all the time in order to maximize the CPU utilization. The objective of time sharing is to switch the CPU among processes so frequently that user can interact with each process while running. So to do this, the process scheduler selects an available processes for execution onto the CPU. Different scheduling queues are maintained in order to execute the processes. The job queue is the queue with the set of all the processes in the system. The ready queue is the set of all the processes residing inside the main memory, ready and waiting to execute. And the device queue is the queue which is the set of the processes waiting for an IO device. So these are the different queues which are available in the system. So once the process get allocated to the CPU and is executing, one of the following event occurs. That is, the process may issue an IO request and then place into the IO queue. The process may create a new sub-process and waits for termination of the sub-process. The process may be forcefully removed from the CPU as a result of interrupt or the time slice expire and again put into the ready queue. So in any of the situation, the process goes into the wait state, completes its task and again ready into the ready queue. So this is how the process is represented with the help of queuing diagram. It consists of rectangles. So rectangles denotes all different queues, that is the ready queue, IO queue or the job queue. The resources are denoted by the circle, that is the IO resources are there, then the CPU is one of the resource which is used. Then the arrow, it denotes the flow of the processes. Now, the processes are available in ready queue. One after the another, the processes are assigned to the CPU. But after partly executed, one of the following event occurs and the process goes into the wait state. Say for example, if the process want to do the IO related work, so the IO request is there and the process goes into the IO queue. Once the IO related work get completed with the help of IO devices, the process will be able to ready into the ready queue for further execution. Another situation occurs when the time slice expires, the process again goes into the wait state and then it will be again goes into the ready queue for further execution. Another situation is that when the process goes into wait state, when the child process or it gives birth to the child process, so the process will fork a child, will execute the child process, and once the child process execution get completed, then again the process will be ready into the ready queue for further execution. And the another situation occurs that when the interrupt is generated, so after solving the interrupts or after executing the interrupt, again the process will goes into the ready queue for further execution. So this is how the process scheduling within the memory, the process is executed, and after waiting, after it goes into the wait state, it will perform its operation or complete its operation and further continue its execution. So these are the different queues shown in the figure. That is, the ready queue is there, which is in the main memory. Then the IO device queue is there. So the queue, ready queue, it consists of the queue header, which has the head pointer and the tail pointer. The head pointer, it points to the process which is at the head of the ready queue. The tail pointer points to the process which is at the tail of the point ready queue. Now let us see the scheduler. The processes migrates among the various scheduling queues. That means some processes may use the job queues, some may use the ready queues, or some may use the IO queues. The selection process is carried out by the appropriate scheduler. So basically the types of schedulers are short-term schedulers, long-term schedulers, and the medium-term schedulers. The short-term schedulers are also called as the CPU scheduler. It selects which process should be executed next that are ready to execute and allocates the CPU to them. Sometimes only the schedulers that are available in system are the CPU schedulers or the short-term schedulers. These are invoked frequently, that is in a milliseconds, because the processor immediately picks the processes from the main memory. That's why it is fast. Another type of scheduler is the long-term scheduler. We used to call it as a job scheduler also. Selects which processes should be brought into the ready queue from the mass storage devices for execution. So whatever the processes that are available onto the secondary storage devices that are bring into the main memory or into the ready queue for execution. Long-term scheduler is invoked infrequently, that means in the seconds or minutes. So it may be slow. The long-term schedulers, this controls the degree of multi-program. That is the number of processes in the memory. Degree of multi-programming, it is the number of processes in the memory. So if the degree of programming is stable, then the average rate of process creation must be equal to the average departure rate of the processes leaving the system. Thus, the long-term scheduler may need to be invoked only when the processes leaves the system. That means whenever the process leaves the system, at that time only the long-term scheduler, they brought the new processes into the ready queue. Now, processes can be described either as IO bound processes or the CPU bound processes. IO bound processes are the processes which spend more time doing the IO related operation than the computation. Whereas the CPU bound processes are the processes which spend more time doing onto the computation rather than the IO related. Long-term schedulers are the good stews for the mix of both, that is the IO bound and the CPU. Another type of scheduling is medium-term scheduling. The time-sharing system may introduce an intermediate level of scheduling, and we called it as a medium-term scheduler. It can use to reduce the degree of multiprogramming. So the key idea behind this is it removes the processes from main memory, store it onto the disk for small amount of time, bring back in from disk to continue the execution where it left off, and the concept is nothing. We used to call it as a swapping. So swapping may be necessary in order to improve the process mix or change in the memory requirement. So this is the diagrammatic representation that you can see related to the medium term scheduling, in which the processes are available or ready into the ready queue, get executed by the CPU. Sometimes if the small amount of waiting time is there, then it goes to the wait state. It will do the IO related work and again continue in into the ready queue and proceed for the rest of the execution. Sometimes the once the partial execution of process get completed and the process is in wait state for a longer period of time without doing any work, then in such a situation the processes may swapped out for some amount of time. That is, partially executed processes are swapped out, and then later on, once the high priority processes get executed, then the partially executed swapped out process is again swapped in, and then the it is available in the ready queue, and then it will continue its further execution. So this is how the swapping will help to improve the process mix as well as the change in memory requirement. So this is in short, we can see that the scheduler, these are nothing but the special software which handles the process scheduling, and its job is to submit the processes and to decide which process to run or execute. Types are long term, short term and medium term. So long term schedulers are related to job scheduler. It determines which programs to admit it into the system for processing. The frequency is infrequent or it runs infrequently, and it decides the degree of multiprogramming. Short-term schedulers, CPU schedulers used the short-term schedulers. It runs very frequently and in the order of 100 milliseconds. And it must very quickly swap one process out of the CPU and swap in another process for execution. That's why the short-term schedulers are faster. In medium-term schedulers, when the system loads get high, so the scheduler will swap one or more processes out of the ready queue for some amount of time or few seconds in order to allow the smaller, faster jobs to finish up quickly and clears the system. And later on, the swapped out processes are swapped in and continues the execution. So this is all about the schedulers and its types. Now let us see about the context switch. So interrupts cause the operating system to change a CPU from its current task and to run a kernel routines. So when an interrupt occurs, CPU switches to another process. So when this happens, the system must save the state of current process and load the saved state of another process or different process, and this task is known as context switch. Context of a process, it is represented in the PCB. Context switch, it is nothing but the context switch time is the overhead. That means in this time the system does no useful work while switching from one process to another. Now, depending upon the system's architecture, The speed varies depending on the memory speed, number of registers, and the existence of special instruction. The more the complex operating system and the process control block, the longer the context switch time will be there. Time dependent on hardware support also. That means some hardware provides multiple sets of registers for CPU. Then in such a situation, multiple contexts loaded at once. That means at the same time, more than one context switch may happens over there depending on to the hardware support. So this is all about the context switch. In short, we can say that when the CPU switches from one process to another, the task is known as a context switch. So while doing this, the system has to save the state of the previous process and load the state of the current new process. So this is all about the scheduling queues we discussed in this session, that is the job queues, ready queues and the device queues. Then we discuss about the schedulers, that is the long-term schedulers, short-term schedulers and the medium-term schedulers and related to context switch. Thank you.